Graphing quadratic functions in standard form. At the end of this lesson, you will be able to graph a quadratic function when it's given to you in standard form. You'll continue finding the axis of symmetry and vertex because these values can be used to create a table of values so we can graph. First up, we have to create a table of values. If a domain is given, if we are given a domain, we just use those values to create the table. But when a domain is not given, we need to find the vertex first and then record at least 7 ordered pairs because our XY chart will still always have the vertex in the center, and then we'll count backwards 3 and forward 3 points at least. After that, we will graph the parabola on the axes. We will always plot as many points as possible unless we have a specific amount of values from the domain, and then we will label the function with the equation. So let's get started. For problem 1, we are asked to graph the function f of x is equal to x squared over the interval from -3 to +3. So this is my domain. This is my list of x values. It tells me where to start my x values in my table, and it tells me where to stop. So I'm going to use these values here for my input. 0, 1, 2, 3. Okay, so now I can use my calculator. I'm going to go into y equals, and I'm going to type in this function right here. I'm going to type in x squared, and I'm going to hit graph to get a preview. And then I'm going to use my table by hitting second graph. Here, we decided that we wanted to start our table at -3. So I'm going to find that window of values, and I'm going to copy them down. 9, 4, 1, 0. So my output values are 9, 4, 1, 0, 1, 4, 9. This should make sense because if I input -3 here and square it, I get +9. If I input -2 here and square it, I'll get +4. We'll see that our vertex happens to be in the center, and I know that because I see the pattern going on above and below the vertex. Okay, so now let's go back to our steps. We have our table of values. We were given a domain, and now we can start graphing. All right, so let's graph. If I plug in -3, I'm supposed to plot at +9. If I plug in -2, I'm supposed to plot at +4. -1 goes up 1. Remember, you always crawl before you learn to jump. So for the next point, I crawl 1, jump 1. Crawl 4, crawl 2, jump 4. And then crawl 3, jump 9. Okay, we're going to connect the smooth curve as best as we can. And I do not use arrows. Let's add that to our notes here. When a domain is given, this means no arrows. Okay. I was told specifically where to start and stop. So we've got our table of values, we have our vertex, we have no arrows, we've graphed. Now I need to label it with the equation. This function is f of x equals x squared. All right, let's answer the questions at the bottom. Our vertex is another name for our turning point. So it is located at 0, 0 here. It's also called my vertex. Okay. How many x-intercepts does this function have? Well, it only crosses, remember, x-intercepts are where we cross the x-axis. And it only crosses the x-axis here. There's only one at 0, 0. And then as far as y-intercepts, this is where it crosses the y-axis. And there's only one as well. I only touch the y-axis at that same point, 0, 0. Well, this function has a special name because it is the most basic form of a quadratic function. It is a positive a value. It's a regular smile with the vertex passing through the origin. It did not move up, down, left or right, has not been stretched or compressed. We call it the same as we did with a absolute value function. It is called the parent function, the most basic form for a quadratic function, meaning x squared. All right, let's take a look at example 2. But how do I know how to graph it if it did not give me a domain? So now I can't just assume that every single graph will start at -3 and stop at +3. So instead, let's go back to our notes, and it says when a domain is not given, we have to find the vertex first. Well, we've been practicing finding the vertex. To find the vertex, I need the axis of symmetry. So let's write find vertex. It's on the axis of symmetry. So to do this, let's start out with our axis of symmetry formula. So if A is -1, B is 2, and C is 5, A is equal to the opposite of B over 2 times A. So I have the opposite of B over 2 times A. X equals -2 over -2. So our axis of symmetry is at +1. So if this is my axis of symmetry, to find the vertex, now I plug in this value. So I'm going to say, what is f of 1 equal to? And when I substitute this into my calculator, I end up with, let's clear this out, the negative of 1 squared plus 2 times 1 plus 5. We are told it will give us an output of 6. And that is again because we substituted the opposite of something squared plus 2 times something plus 5. We plugged in 1, and this is what we got, a 6. So our vertex is 1, 6. Okay. Well, now we have to plot at least 7 values. So I should count backwards 3 values, at least, and then forwards 3 values. So my table for this problem will range from -2 to 4 for the domain. Let's find the range values, the output values. Instead of substituting them one by one, let's go into y equals, let's clear this out, -x squared plus 2x plus 5. Let's take a peek at the graph. It definitely moved. It's also changed to go upside down. We know that because this front number for A is negative. Let's take a look at our table and get what we need. We want our table to start at -2. Let's copy down our values. We're told -3, 2, 5, 6, -3, 2, 5, 6. So 6, 5, 2, -3. All right, we're ready to plot. So now crawl backwards 2, fall down 3. Crawl on the ground backwards 1. Oops, and jump up 2. So we're going to go over 1, up 2. Crawl nowhere, but jump up 5. 3, 4, 5. My vertex is at 1, 6. And then it starts to turn back down. Because of points of symmetry, it usually helps me graph it a little bit quicker. All right, so now I go to connect my points, but my graph should look slightly different than the graph in number 1. This time, there was no domain given, so this will technically keep on graphing. Let's take a look and see where the next point would be. It would actually hit all the way at -10, which I can fit. And I can fit, even though it's not on my graph, I do know that this function is going to go on forever. So I'm going to connect it with arrows at the end. Might as well graph as far as I can go. All right, let's label this function. F of x equals -x squared plus 2x plus 5. Now this graph has two x-intercepts. My x-intercepts, again, are where we cross the x-axis. Look for them, and we're going to identify them. They're here and here. It just asks how many. There are two. And I can't state exactly where they are because they seem to be fractional or decimals. But that's okay. So now, how many times does this cross the y-axis? Let's check. We're crossing the y-axis for the y-intercepts. That's only once. And we could see that value. There's only one at 0.5. Okay. Something else that's also important is that at the very beginning of this problem, I noticed that A is negative. Automatically, before I even took that preview in my calculator, I knew that it was going to be a frown face, meaning that it was going to have a maximum turning point rather than a minimum vertex. Just something you want to be aware of for every problem. All right, let's take a look at the last one. It says, how should we begin? We were given this function. Do we need to use our axis of symmetry to find the vertex? No, in this case, we were given the domain. So I'd like you to get started by filling in your domain and range, plotting your points, and answering the questions. Now would be a great time to pause the video, hit play when you're done so you can check your answers. Okay, let's check our answers. First, we should have placed our domain in for our x values and used our calculator to determine the output values. Okay, next up, we plot. So you should have these 7 points plotted. And then notice there are no arrows here. Please be sure that you do not use arrows when you're given a domain. When given domain. Okay. All right, so now let's answer the questions below. How many x-intercepts does this one have? Well, it crosses the x-axis twice. We can actually list them both, but there are two. And then how many y-intercepts? How many times does it cross the y-axis? Just once. So there's one y-intercept. Again, if I look at the beginning function here, my a value, right here, a equals 1 was positive, meaning it's going to be a smile, and therefore this time my vertex is a minimum value. So just to recap, let's see. The first one and the last one gave us a domain, which made it very easy to begin. But how do we know to do without a domain? Well, you have to use your notes. Your notes say if the domain is not given, we have to find the vertex and then record 7 ordered pairs. Well, finding the vertex will require us to use our axis of symmetry formula to get there. So that is how, for problem 2, I began. I had to find the vertex using the axis of symmetry formula. I found the output value and placed it in the center of my table and then moved on. My calculator found the rest of the output values and I was able to carry on and graph. You can now graph a quadratic function if it's given to you in standard form, meaning in this format set equal to a function name. We have to use our axis of symmetry and vertex in the center of our table, and then we are able to use our calculators to get the rest of the output values. Thank you for watching.